So girls, today we are going to discuss about the force. Okay, the force, not Newton's laws of gravity, all those things which we discussed in 9th class, not the force. Girls. Today we'll discuss about the different types of moment of inertias, couples, and how does they act in, what are the examples of all these types of equilibrium, all those we'll study on the first part. What else the second part? So coming to the motion, there are two types of motion. Normal motions, these are one is linear motion and the other is rotational motion. Linear and rotational, very easy. Any body, if it is moving straight, this is called linear. Rotational body, when any body is moving around, that is called rotational body. Here we apply force tangentially. Okay, here we apply force tangentially, and that force is called rotational motion. And here we apply force normally, and the body will go in straight line. Here body is rotating. Here straight line, here it's rotating. These are three, and here the force is applied tangentially. These are two types of motions, very easy. Then coming to next important topic, we have to study movement of force. What is movement of force? So, moment of force is the product of force and perpendicular distance. Perpendicular distance. Moment of force is the product of force and perpendicular distance of force from point O. Then suppose girls, suppose this is your door. This is your door. This is the hinge. So girls, when you are opening, normally here handle will be there. We will hold this handle and we will just move inside or outside. We will push up. So here we are applying force. Here we are applying force like this, and this is moving along this around this hinge. Okay, so this force and this perpendicular distance, this perpendicular distance is moment of force. Moment of force. Okay, or like suppose when you are having screws, when you are having screws, okay, they are fitting. So what will do? You use some type of what will say this? Okay, some screwdriver or something like that thing we will use, and we will here hold here, and we'll just will be doing like this. Okay, and we will rotate it. This will rotate it around it, and you will get it. So here we are applying force, and this is the perpendicular distance. This force into perpendicular distance cause the moment of force. So moment of force, formula is force into distance, perpendicular distance. How much distance it is acting. So girls, now you tell me, when you are opening the door, if you hold it here, it will be easier. If you hold here and if you move, it will be easier. Tell me, girls, where it will be easy to move? You
Away
go.
from the hinges, sir.
Yeah, as you go away, the force will become less. No, sir, I want to move. I will touch here and I will move. It becomes very difficult. You can move. It becomes very difficult. As the perpendicular distance increases, force decreases, and moment of so this moment of the turn, this moment of inertia, because of the moment of inertia, the body turns. This is called as the turning effect of the body about the axis due to this moment of force is called torque. Okay, so this moment. So what is this moment of force is called torque. What is the torque? The torque is moment of force. The torque is what is torque is called moment of force.
Moment of force.
For the torque only, the other name is moment of force. So the moment of force or torque is equal to what? Product of force and this perpendicular distance. Product of force and perpendicular distance. Okay, so the torque and moment of force. It gives what the torque or moment of force is responsible for turning effect. It's responsible for the turning effect. So force into distance, some perpendicular distance. Units. This is newtons. This is meter. Newtons into meters in SI system. No, sir, I want in CGS systems. Means dynes into centimeters is CGS system. It's up to you. Okay, whichever one you want, you can use. Okay, children. So, what are the factors on which this torque depends? Number one, force. Number two, distance. How much force you apply, that much strong, fast it will move, and how much far it is, that much less force you can apply. Okay, the distance of the line of action of force with the axis of rotation. Okay, so this torque depends upon force and distance. as the formula indicates, force and distance. So torque depends on what are the factors. One mark question: force and perpendicular distance. Units: Newton meter or dynes into centimeter. Children, SI to CGS conversion. 1 Newton meter. Children, 1 Newton is how much? 10 to the power of 5 times. Do you know how to derive this, or shall I show, children? 1 Newton is 10 to the power of 5 times. You know, or shall I show? Tell me fast. Girls,
Sir, I don't know, sir.
shall I show?
Yeah, sir.
Okay, I will show. Okay. So 1 Newton is, I will show, 10 to the power of 5 times. 1 meter is 100 centimeters. So 1 Newton meter is equal to 10 to the power of 5 plus 2, 7 9 centimeters. Okay. So if you don't know how you got 1 Newton is 10 to the power, 1 Newton is 10 to the power of 5 times. How you got that also? I will show. Once see here. Normally, force is equal to mass into acceleration in ninth class. We studied Newton's second law. So this 1 Newton can be defined as 1 kg and acceleration is meters per second square. 1 Newton. 1 kg means 1000 grams. 1 kg means 1000 grams. 1 meter means 100 centimeters per second square. So 1 Newton is equal to 1, 2, 3, 4, 5. 10 to the power of 5 grams centimeter per second square. So 1 Newton is equal to 10 to the power of 5 grams centimeter per second square. We can write it as dynes. So 1 Newton is equal to 10 to the power of 5 dynes. That only I directly substituted here. So this is in SI system, this is in CGS system. 1 Newton meter is 10 to the power of 7 dynes centimeters. Okay, this is about moment of inertia. And clockwise and anti-clockwise movements, conventionally, children, if the body is on the effect of body, okay, if the effect on the body is to turn in anti-clockwise. So anti-clockwise is like this locals. If the effect on the body is to turn anti-clockwise, see here, the moment of force is called anti-clockwise movement. And always, please try to remember, anti-clockwise is taken as positive in our physics. And in clockwise, the moment of force is called clockwise movement, and clockwise is taken as negative. And remember, children, the moment of force is always a vector quantity. What is a vector quantity? It will have magnitude and it will have direction. It is a direction is very important because clockwise, anti-clockwise have evolved, and also it has magnitude. Of course, everyone has magnitude. Okay, it's a vector, and direction of anti-clockwise movement is along the axis of rotation outwards, while the clockwise movement is along the inwards. Clockwise means inwards, anti-clockwise means outward. Clockwise means inward, anti-clockwise means outward. Okay, and if ever anyone asks you dimensional formula, will you be in a position to write dimensional formula, girls? Those who don't know dimensional formula, please, yes, girls. So clockwise means negative, anti-clockwise means positive, and dimensional formula. If ever anyone asks, what is the force into distance, locals? Force means mass into acceleration into distance. Acceleration is what? Meters per second square into distance. Distance means some meters, and mass means what? Girls, kgs. Okay, so dimension formula is m per kgs m m into m mass square L square, and this goes up T minus 2. Girls, do you know dimensional formula or not? Dimensional formula, it is written, dimensional formulas for all the units will be in the form of MLT. Here one mass is there, one mass. Two distances are there, two distances. Time is down if it comes up minus 2. Time is down if it comes up minus 2. So what is the dimensional formula of torque means ml square T minus 2. So children, this is about torque there. And if you see some of the examples of the torque, so common examples, opening and closing of the door. Okay, opening and closing of the door is the best example. Or else, okay, one more example. What we will give children when you are cycling, when you are cycling. Here, this is your pedals will be like this one. Here you will apply force. This is the perpendicular distance. Here you will apply the force. This is the perpendicular force into perpendicular distance. Okay, girls. Or your car steerings. Car steerings will be like this, girls. Car steerings. Here we will apply force, and this is the perpendicular distance. Here we will apply force, and this is the perpendicular distance. These are some of the common examples of moment of inertia, and even opening of spanner and that's one screw I told. Spanner and screw I told first to it. This is spanner, and this is opening of screw by spanner. Okay, so from all this, what we came to know, torque causes moment of force. Torque or moment of force causes this is a door. Around the fixed support, it will move. Around the fixed support, it will move. Okay, around the fixed support, anything around the fixed support, if it moves, it's called torque. So girls, so torque or moment of force formulas force into distance. Force is newtons, distance is meter, or force is dynes, distance is centimeter. This is SI, this is CGS. 1 Newton meter is 10 to the power of 7 dynes centimeter. And it is a vector, but it means it has magnitude and direction. And clockwise we will take as negative, anti-clockwise we will take it as positive conventionally. And dimensional formula of torque is m square t minus 2. And some of the famous examples are opening and closing of the door, opening and closing of the nut by a spanner, and moving of a car steering, and around a fixed support machine. Around the fixed support, okay? And the movement of the movement of cycle wheel with pedal, and this wheel is moving. This is force. Sorry, this is force. This is distance. This is force. This is distance. These are some of the examples of torque or moment of force. So how do you define torque or moment of force, girls? The torque or moment of force is equal to product of force and distance. It's equal to product of force and perpendicular distance. Product of force and perpendicular distance. Should not forget, children. This is torque or moment of force. Okay, girls. Anyone have any doubt in this? Then if you don't have doubt, then we'll go for couple. So, children, we have discussed about torque. Okay. Torque we discussed all the points. Once I will revise and I will write here so that you will have for revision at the last. Torque is equal to force into perpendicular distance. Okay, it is also called as moment of force. Okay, it is a vector quantity, and the units are Newton meter or dynes centimeter. 1 Newton meter is equal to 10 to the power of 7 dynes centimeter. It is ml square t minus 2. Clockwise we will take it as negative, anti-clockwise we will take it as positive. Torque or moment of inertia causes a movement around the fixed support. Movement of body around the fixed support. Some of the famous examples we have to give. That's all we studied children till now. Torque. Now, girls, we'll study about couple. Couple. So, girls, couple is also same amount, same like couple is also. But here at a time, imagine this is your tap. Imagine this is your tap, girls. Your tap. Okay. So how do you hold the tap? No one will hold like this and they will move like this, like this. No one. We will hold like this. No, we will hold like this. Here one force, and so when you are holding it, one force will come from here, one force will come from here. Okay, so one force you will apply here, another force you will apply here, opposite direction. And imagine this is O, this is A, this is B. So girls, for couple, what you're at, first moment of inertia, torque one, I would say. But this first moment of inertia is force into OE. Second moment of inertia is caused because of force into OE. When I join this both, now couple is equal to sum of the moment of inertia. What is first moment of inertia and second moment of inertia? So first moment of inertia is F into OB. Second moment of inertia is F into OA. And force is common, OB plus OA. So F into OB plus OA is AB. AB means again, what is AB, girls? It is distance only. Force into distance. Again, you got same. What is couple? Moment couple. It is also either force, any one force, both, because same force will apply on both sides. One side more, one side less. No one will apply on that. Both sides same. Either force, any one of the force into distance between the forces. Okay, girls. So couple is any of the one force into distance between the two forces. Distance between the two forces. Girls, indirectly same formula for torque and couple. Indirectly same. But in torque, force into perpendicular distance one, and in couple, any one of the force into perpendicular distance between both of them. Here, this is couple. And girls, this is also causes turning effect around one direction. This is also causes turning effect two in the same direction. This also causes turning effect. But finally, torque and couple has same formulas. What is that? Force into perpendicular distance. Now, what are the types of equilibrium we have? We have static equilibrium, dynamic equilibrium. What is static equilibrium? Girls, what is that? When a body is at rest. When the body is at rest. Okay, any body. This will be under rest because of this force and this force are cancelling each other. This force and this force are cancelling each other. This force and this force. So many forces will cancel each other, and overall it will remain at rest. That is static equilibrium, like some of the examples. Anything which is at rest, anything which is at rest is called static equilibrium, like a book on the table, a stone on the ground, anything. Another one is dynamic equilibrium. What is dynamic equilibrium? The equilibrium which is there when a body is moving either straight line or circular. One nice example I will give you. Suppose this is the sun. Around the sun, our Earth is moving. How it is moving in that much equilibrium our Earth because of centripetal and centrifugal forces will balance each other. Neither it will come inside nor it will go outside. These both forces will cancel each other. Okay, suppose children, you are standing here, your hands. From here, one fellow is pulling you. From here, one fellow is pulling you. Where you will go? If they both pull with same force, you will remain in the middle only. If someone pulls with more force, then you will go that side. But when both of them are exerting same forces, you will remain in the middle. That is called dynamic static equilibrium when you are at rest. And when the body is moving, also it is in equilibrium with dynamic equilibrium. Okay, an aeroplane moves at constant height when upward lift balances weight. Okay, so aeroplane is there, is going downward force will be equal to upward force, then it will be equilibrium at certain height also. Okay, a stone is tied and we are moving like this, like this, like this. It is in equilibrium. How outermost force is equal to innermost force acting. So, girls, anybody to be in a state of equilibrium, remember all the sum of all forces should be equal to zero. If this is 10, this should be minus 10, or whatever it may be, sum of all the forces acting on that body should become equal to zero. Then only body will be in equilibrium. And sum of all movement of forces also should be equal to zero. Sum of all forces, sum of all torques, moment of force also should be equal to zero. Then only we can say body is in equilibrium. When all the forces are equal to zero, when all the torques are equal to zero, then only we can say body is in equilibrium. Okay, so next one, principle of moments. Okay, what is principle of moments? So girls, principle of moments means it's simple. Take a meter scale. It's like your weighing machine, girls. It's like weighing machine. But here, principle of moments, you take a meter scale and suppose at one end you are adding some weight. At one end you are adding some weight. Okay, so this we will say it as L1. This we will say it as F1 or W1. And here we will add some weight W2. Okay, normally we should add here. Okay, normally. Try to understand, children. Here we should add. And this is it. Then you will say, no, sir, I want to add this time. So this has to be balanced. It means girls, listen. Let me say, wait, no, this is weight. I will say, okay. Then girls, if this has to be stable equilibrium, means W1 into L1 should be equal to W2 into L2. Then only it will be in equilibrium. This into this should be equal to this into this. No, sir, I will put this weight here only means you may say will put instead of here only I will put sir means it may change now. You have to put more weight to balance it. To balance it, you may have to put more weight. Okay, girls, you are able to understand. Here, no, instead of putting girls, here, weight, I want to, sir, I want to put not here, sir, I will put here only, you will say. Imagine these both lengths are same. I want to put weight, then I should put more weight to balance the scale. It depends. That the formula is, principle of movements formula is W1 into L1 should be equal to this whole thing should be equal to W2 L2. Then principle of moments. If you do some numericals, children, then you will understand. Okay. If you do some like some simple example, I will show you. Simple example on this I will show you. Then you will understand. Small example. Okay. Suppose here 30 kg is attached. Okay, at the distance of 20 centimeters. Okay, and here at 30 centimeters, I want to put something 30, not 20. How much should I weigh put so that the whole scale will be in equilibrium? That is my question. Try to understand. Try to understand. At 20 centimeters, I kept 30 kgs. At 30 centimeters, I want to keep some weight. how much should I keep? So you'll find out W2 into 30 is equal to 20 into 30. So 30, 30 gone. At W2, you should give 20 kgs. If you keep 20 kgs, then it will be balanced. Okay? Or like same sum they may ask like this also. Same sum they may ask like this also. See, check. Then only you will understand it. See, I am putting 40 kgs at 50 centimeters. Okay? So how much should I keep? I don't want to keep 40 kgs, I want to keep 10 kgs only. I want to keep 10 kgs only, but still I want it to be balanced. Then at what distance I should put 10 kg so that this whole thing is still balanced. Simple. 10 into L2 is how much? So that it should balance 50 to 8. This gone. 40. You keep it at 40. You keep it at 40. Right? There's a 40 numbers. So at 40 centimeters, if you keep 10 kgs, it will balance 50 centimeters, 40 kgs also it will balance. Like that. This is called principle of movements. What we are doing means sum of all this side forces is equal to sum of all this side forces and balancing. Then you will get principle of movements. So girls, till now what did I say? I told first one torque. What torque force into displacement, and it's a vector quantity. Units is Newton meters. Here also Newton meters only. Okay, and the dimensional formula is ml square t minus 2, and clockwise will take negative, anti-clockwise will take positive. Couple is two forces and the distance between them. Two forces and the distance between them. Here also force into perpendicular distance. Okay, force into perpendicular. Next, types of equilibrium I told: static equilibrium, dynamic equilibrium. Next, I told principle of movements. In principle of movements, total forces acting in this direction will be equal. Total forces acting in this direction. Then this will be in balance. Sum of all forces acting in clockwise should be equal to sum of all forces acting in anti-clockwise. Sum of all forces acting in clockwise should be equal to sum of all forces anti-clockwise. Then it will be equilibrium. Like this you have to do. If you practice exercise, then you will become perfect. All the exercises which are given at the end of the lesson.